Hello. In this video, we're going to look at an alternate algebraic method of solving systems of equations when the substitution method is kind of impractical. So consider this system of equations, 2x plus 3y equals negative 3 and negative 3x minus 5y equals 4. In order to use substitution, I have to isolate either x or y in either of these equations. But to do so, no matter which variable I choose and no matter which equation, is going to introduce fractions. Certainly that's acceptable and you're able to do that. So for example, I could choose to turn this first equation, dividing everything by 2, it would become x plus 3 over 2y equals negative 3 over 2, which I could then isolate x into being negative 3 over 2y minus 3 over 2. And then I could substitute this into the second equation, minus 3 times x, which is being replaced now with negative 3 over 2y minus 3 over 2, and then minus 5y equals 4. And I can solve from here, and that is doable. It's just not especially desirable. So what I can do instead is I can look at both of these equations and I can create a comparable equation where I have matching coefficients for one of the variables that would allow me to eliminate. And I can choose to eliminate either x or y. It entirely depends on personal choice. But what I'm going to do in this case is I'm going to eliminate x. So I'm going to take the first equation and I'm going to multiply it by 3. So 3 times the first equation. And then I'm going to take the second equation and multiply it by 2. And hopefully, if you're not seeing quite why I've chosen those numbers yet, it will become a little more obvious as I go through. But if I take that first equation and I multiply everything by 3, then I get 6x plus 9y equals negative 9. This equation is entirely equivalent to the first equation. I've changed the coefficients, but I haven't changed its truthfulness. I haven't changed the values of x and y that make it true. And in the second equation, if I multiply everything by 2, then I get negative 6x minus 10y equals 8. Now, what that allows me to do is to say that I have now the same coefficient, essentially, for x in both equations, except one is opposite. And actually, them being opposite makes this a little easier, because what I can now do is I can add these two equations together. The reason I can do that without changing the truthfulness of everything is because if I consider the left-hand side of this equation sort of as one thing, if I add those two together, I'm essentially adding together negative 9 and 8 because the left-hand sides are equal to negative 9 and 8. So the sum of negative 9 and 8 is negative 1, but the sum of 6x plus 9y and negative 6x minus 10y also has to be negative 1 because they're equivalent to each other individually. Well, when I add 6x and negative 6x, they disappear. When I add 9y and negative 10y, I get negative y, which means that y is equal to 1. If I had done all of the work with the fractions that I started out with, I would have ended up with this exact same value, and I'll leave it to you to check that if you like, but I would have gotten y equals 1. And now what I can do with that value is substitute it into either one of my original equations or the modified equations with the bigger coefficients, but I would prefer to use smaller coefficients, and figure out what x would have to be. In other words, 2x plus 3 times 1, which is 3, would have to equal negative 3. So 2x has to equal negative 6, which means x equals negative 3. And the solution to this system is therefore the point negative 3, 1. That's exactly the same thing I would have gotten with substitution, but I got to do it without having to work with fractions. Now, I could have chosen from the start, instead of multiplying the first equation by 3, let's say I had multiplied the first equation by 5. And then I would have chosen to multiply the second equation by 3, because this would have eliminated y. What I would have gotten had I done that multiplication would have been 10x plus 15y equals negative 15. I'm going to just shuffle over a little bit. And in the second equation, multiplying by 3 would give me negative 9x minus 15y equals 12. And what I would then get when I add these two together, well, now I have the y values are going to cancel because 15y and negative 15y cancel out. 10x minus 9x is just x, and negative 15 plus 12 is negative 3. You see I end up with the exact same value of negative 3 for x. And if I substitute this back into one of my original equations, I will get y equals 1. So I choose coefficients, I choose multipliers that are going to allow me to eliminate coefficients. So let's look at this example then. In this example, I could choose to multiply the first equation by, let's say, by 2, and the second equation by 5 in order to eliminate y. But actually, if I look at the x values, I don't need to multiply the second equation by anything at all. I just need to multiply the first equation by 2. So if I multiply 2 times the first equation, so 2 times equation 1, notice I'm communicating what I'm doing. This can help somebody follow your work so that they can see where this new equation is coming from. So 2 times the first equation is 4x plus 10y equals 16. And then the second equation I'm going to leave alone. So 4x minus 2y equals negative 8. So I'll just write that I kept that equation as it was, 2. This time, in order to eliminate the x variable, I'm not going to add these two equations together. I'm going to subtract. So I have to remember that I'm subtracting both parts. So 4x minus 4x, that's gone. But 10y minus negative 2y is actually the same thing as adding 2y, so I get 12y. So if you're subtracting, you have to be careful. And same thing for the negative 8. 16 minus negative 8 is like 16 plus 8, so that equals 24, which means that y is equal to 2. And I can now go and figure out by substituting into either one of my original equations. I'll use the first equation. So 2x plus 5 times 2 equals 8, which means that 2x equals 8 minus 10, which is negative 2, x equals negative 1, which means that the solution to this system is the point negative 1, 2. One small note I'll make here, if you would rather not have to subtract, because then you have to remember what's happening with signs, you can definitely add. The way to do that would be, in the first case, instead of multiplying the first equation by 2, I could multiply it by negative 2. Or I could just immediately multiply it by 2 and then multiply negative 1 times the second equation. And that would sort of save me having to subtract. So I would get 4x plus 10y equals 16. And then I would have negative 4x plus 2y equals 8. And then I can add. So I don't have to worry so much about what's going on with my subtractions. This gets me to exactly the same place. It gets me to 12y equals 24, which leads me back to where I was. So you can just multiply and then subtract, or you can choose to always multiply by something that's going to allow you to add, so you're maybe less likely to make a mistake with your subtractions.